Like I said, I didn't even attempt to familiarize myself with the mechanics, and that shows. The first attempt at using the debugger ended in total failure. What's up everybody, it's Izzo. Welcome to the lab and welcome to Devlog 12. It's crazy we're already in March, but welcome to the first official project of the year. Before I start to explain today's experiment, let's look at this footage from Devlog 11. We're in trouble. It's okay, I got food. Let's hope we can get back to the house. The lag is immaculate. Not fine again. This is not, oh god. I feel like I'm in space. Like, look at this. I wish I knew what the FPS was right now. I swear, it's probably like 20. Getting down to like 15. Those cuts didn't actually make it to Devlog 11. I figured it'd be annoying if I kept complaining about the lag, but that's what we're here for today. We gotta make Codename All Night more bearable to play by trying to decrease the lag. Again. Don't worry, we're not upending an entire system or breaking the game today. Thank God. So if it's not saving, what could be causing the lag, you might ask? Well, I mean, this nightmare codebase could be the overall cause, but let me stop being dramatic. From playing the game, here's our bug list. Number 1, the buildings. There's really 3 objects per building instance that we see in game. Number 2, the segment settings. Remember, a segment is a container for chunks. Well, there's too many chunks allowed in one segment. That results in too many objects on the screen, which will increase the lag, so we gotta fix that. Number 3, the skeleton entities. There's some lag with these guys, so we're gonna experiment with them and see if we can fix that. Number 4 are the village environments. They lag out the surrounding chunks, and there's some problems with the villagers in general. Mainly, they should be inside at night. They are not inside at night. Now, the dilemma. 3 out of 4 of these things on this list are huge topics that require their own devlogs. So, welcome to the Expulsion of Lag, Series 2! So, first up on the old agenda for today is tweaking the housing mechanics. Before that, let's crack into how the housing mechanics work. Basically, how we get that effect of the exterior view, then the interior view. There's 3 objects in total for each building. Basically, you can look at it like a set. There's the exterior object, the interior object, and the outline object. The exterior object holds all the possible logic of a building, including saving and loading. It also generates the other 2 pieces in its set once it's spawned in. So for every building that spawns in, it has 3 objects that exist to get that full housing experience. That's where our mission lies. We decrease the number of objects that exist on the screen in one segment by taking out the existence of the outline and the interior objects. Basically, when the player is outside the house. They're only going to spawn in when the player is inside the house. In turn, that should decrease the amount of lag. Hopefully. And with that, our first version for the new spawning full building set logic is ready. That's a mouthful. Anyways, let's go over these changes. First, each set of objects needs their own properties updated. The exterior object gets a new flag called outline spawned. Then we're renaming the original flag used for spawning a building set to interior spawn. For the events, we just took the original event and split it into 2 events, one for each part of the house. Now we can process the spawning and destruction of each building object separately, which comes in handy in just a second. Now we can work on the destruction logic, and I'm not gonna lie everyone, this is where things get iffy. We need a way to continuously check for if a building is activated, basically if a player is inside the building. The best way to do that is a loop, but now this is where poor design comes to bite me in the butt. All the exterior building objects need to have a common property, the same name at the same index, that I can use to basically select the object and see what's going on with it. These objects all have varying amounts of values in different places. The only way to get around this is to find the building that contains the most values and then add one to that. Then go back and make all of the other buildings have that one value in common. Honestly, it irks me to do it this way, but hey, let's just keep on keeping on. Now we can create that loop control we need. It'll iterate through all of the building exteriors. The qualifier 0 is the way to group all of the building objects together. Thankfully, that was thought of before this. And then we'll connect them all through a value called connect ID, the 21st value on all exterior objects. With all of the loop and object grouping madness out the way, we can continue with redoing the building mechanics. Alright, we got our first version of the destruction logic stomped out. What's going on is we're using that loop that we put together to iterate through the buildings, select a specific building, and check if its activated flag is off while its set flags are on. That basically means those pieces are still in existence and they shouldn't be. The player is no longer inside the house. So using the ID, it selects the correct interior and outline objects, destroys them, and turns off their respective spawning flags. Whew. And after all of that, it's time for the honorary initial test. Before we add this everywhere else, let's make sure that what we got works. Alright guys, this test is pretty simple, especially since the library is the first building we see. All we're gonna do is spawn in, then go inside the library and make sure it spawns its interior and outline objects, and also it destroys them, depending on the state. Looks like we're good to go. Both objects spawn in and get destroyed depending on if we're inside or outside the building. Now to do this for the rest of the buildings. The good part is it's nowhere near as much reworking as the saving and loading logic. Thank goodness. While moving through, I did realize that none of the exterior buildings tag their interiors and their outlines with their IDs. Not good. The only reason that first test worked is because there was only one of the libraries in existence. If there was more than one, then we would have had problems. No worries, that's been taken care of and we're back to applying changes. Okay, one more stop, the house cube buildings. Their logic is a little more complex and for some reason it's tied to the saving system, just the part where IDs are assigned. Apparently it's used to connect the exterior to the interior objects. That's to sync the exterior sprite and the interior sprite. The house cube buildings are the only buildings that can be upgraded. They all have a wood texture, and with the upgrade tool they can be upgraded to stone, then iron, which upgrades their wall health. But also, I needed to add in their interiors to match their exteriors, like color scheme wise. So also, their sprites, depending on which texture the exterior has, the interior one changes too. So yeah, we'll just call that an early method of accomplishing that, and gently replace everything with the new logic. Now, because we just changed some stuff in this wild code base, we gotta test this real quick. Also, I don't think I've ever showed upgrading the buildings. Little insight, house cube upgrades are meant to be mid-game achievements, so having those for a test game is kinda difficult. That's where our good old debugger comes in at. We're adding some new commands to give us each house cube and each type of material as well. Honestly, I made this harder than what it needed to be. I had already added in commands to give us seeds and planter boxes from a previous test, but I wanted to go one step further and make sure the system tried to add the items to the inventory. Really, it was kind of me being lazy. I don't want to go and add it to the inventory from the bag. So yeah, let's try this out. My first attempt, I took the logic from picking up items. I thought the item collision buffer was used for inventory processing. Spoiler alert, it's not. It's connected to processing picking up items, as the name suggests. Like I said, I didn't even attempt to familiarize myself with the mechanics, and that shows. The first attempt at using the debugger ended in total failure. The house cube wasn't even added to the bag. The second attempt, I started to kind of wing it. Well, I've been winging it, but let's wing it some more. Using some events from the crafting screen as my base, all I did was add in increasing the global value that corresponds with the item in the bag. During testing, that only worked halfway. It got added to the bag, but not to the inventory. The only thing I can say is at least we're getting closer. The third attempt, I took 2 more pieces from the crafting menu event, the look at inventory action, and setting a string called item queue to the specific items names. Those 2 events, fun fact, were actually the events I needed. Whoops. As the name suggests, look at inv looks at the inventory to see if there's room for a new item, while item queue holds the items waiting to be processed. Yeah, this winging it failed, but anyways, with all the debugger commands working, it's time to test the house cubes. Finally. Alright guys, for the full test, we're testing 2 things. 1, if the new housing mechanics are working with the house cube buildings, and 2, if their upgrade mechanics still work since some things got changed around. For the first model of the house cube, we're looking good. It's time to take this test further now. Let's see if the upgrading works. I'm adding some materials to my bag using the built-in debugger. Yeah, I got tired of messing with the commands for the episode, so the lazy way it is. And now for upgrading. We're looking good. The building upgrades and the textures are synced up. Now for further testing and to showcase some of the other house cube models. Let's set up another Model 1 so we can see the mechanics work with the 2 instances of the same building. We're looking good. Alright, let's do a couple more and see how that works. Well, looks like we have a problem with the ladder and the boundaries of this model of the house cube. Looks like something to work on later. For now, let's get back to implementing the new building mechanics. We kinda went on a tangent with that one, but I'm gonna keep reworking things and I'll see everyone back here for the last test. Alright, we're back and we're ready for the last test. This test is actually twofold. First, we're testing as many buildings as we can within 50 chunks to make sure they work. Then we're keeping track of the object count. We're gonna compare this version's object count to the object count of the older version I used to record devlog 11. Look at that, all the houses we tested are working great, and we have an object count of 780. Now let's load in the older version and see how many objects that one has. The great part is we can use the same file so we can get insanely accurate results. For the previous version, we have 810 objects. It's a 30 object difference, which isn't that great, but mind you, we didn't loot or anything. So with the changes to the world, this should have a greater impact on the object counts. All in all, implementation was a success. Alright everyone, that's all we have time for in the lab today, but we're well on our way to expelling more lag in Codename All Night and also making the codebase more robust, which is just amazing. We already got through tweaking how the housing mechanics works, and as a bonus, we got to look at some of the house cubes and their upgrades. I'd say this has been a very successful lab day. For the next devlog, I think we're going to tackle those segment settings and really make a difference in that object count. For now, thanks everyone for joining me in the lab today. Leave a like if you enjoyed today's lab project, let me know what you think in the comments, and subscribe to join me in the lab for more experiments. Alright guys, have a good one, see you for the next one.